Hello friends, how are you? In yesterday class we discussed about pure substances. The substance which is made up by only one type of particles is known as pure substance. And further that we also classified the pure substance, and that was two types. One is element and second was compound. Element, the chemical substance which cannot further divide into simpler form by chemical reaction is known as element. Or if we consider this chemical composition, then we can say that any any matter or any substance which made up by one type of atoms only one type of atoms is known as element. Okay. And then we discuss the types of element. And as you know that there are three types of elements. One is metal, second is non-metal, and third one is semi-metal or metalloids. Okay. The metals which have metallic properties, like they have luster, that means shine, they are ductile, they are malleable, they are good conductor of heat and electricity, they are hard, they have high melting and boiling points. Okay. They are sonorous. That was the properties of metals. Now in today's class we will discuss about the non-metals. Okay. Non-metals. If we consider the definition, then as we described the metals, we can describe non-metal also, according to which we can say that those elements which shows, yeah, which have non-metallic properties are called non-metals. The elements, yeah, those elements which shows non-metallic properties, or we can say that those elements which have non-metallic properties are called metals. Non-metallic properties, that means these are just opposite to the metals. Metals have property which is called metallic properties, and opposite to that are called non-metallic properties. Let me discuss about one by one. First, they found in all states, that is solid, liquid and gas. They are found in all three states. First is some of them are solid, some of them are liquid, and some of them are gases. Okay. Second property, they are soft. Non-metals are soft in nature, but the exception is diamond, which is an allotrope of carbon, which is an allotrope, allotrope of carbon. It is hard substance. It is hard substance. Okay. Next property is they are not lustrous. That means they do not have shine. Non-metals do not have any kind of shine. For example, this paper which is made up by carbon, it do not have any kind of shine. Okay. But there is exception also, that is iodine and graphite. Iodine and graphite, they have shine. This pencil have graphite, that is graphite, the black colored substance, that is graphite. It has shine. And similarly, iodine has a characteristic shine. Okay. The next property, they are bad or poor conductor of heat and electricity. Non-metals are bad or poor conductor of heat and electricity. Okay. But the exception is graphite, which is allotrope of carbon. That one, this black colored. Okay. That is graphite. It is a good conductor of heat and electricity. It is a good conductor of heat and electricity. It is a good conductor because of the presence of the free electron. Okay. Now next one is comparatively. If we compare with the metals, then we can say that comparatively they have low melting and boiling points. The non-metals have low melting and boiling points, but the exception is graphite. But the exception is diamond. It has high melting and boiling point. It has high melting and boiling points. Okay. The next, they are non-ductile. That means we cannot draw them into wires. We cannot draw drawn them into wires. Okay. Next one is they are non-malleable. They are non-malleable. That means we cannot convert them into sheets by hammering. By hammered, we cannot convert them into sheets. Okay. They are not sonorous. Sorry. They are not sonorous. That means they do not produce any kind of ringing sound when they heated. When they heated like that, they do not produce any kind of ringing sound like we hit the metal. Okay. Now, if we consider its example, then hydrogen, oxygen, iodine, carbon, bromine, chlorine, nitrogen, etc. comes in the category of non-metals. Comes in the category of non-metals. And now the third type of elements. These are semi-metals. These are semi-metals or metalloids. If we consider its definition, then we can say that some elements have intermediate properties. That means with the properties of that elements is between metal and non-metal. Some of the properties are similar with the metals, while some of the properties are similar with non-metals. Okay, clear? So they have intermediate properties between metal and non-metals. Such elements are called semi-metals. Let me repeat it again. Some elements have intermediate properties between metal and non-metals. They are called semi-metal or metalloids. If we consider this one more definition, then we can say that some elements some elements which shows or possess the properties of both metals and non-metals, possess the properties of both metals and non-metals, are called semi-metals or metalloids. If we consider this example, then they are boron, silicon, germanium, gallium, etc. They come in the category of semi-metals. Okay. Now let me discuss some facts about the elements. At present time, there are more than 100 elements are known. As per the IUPAC, they recommended 118 elements. I am not using fixed value here because this value is changed as per the IUPAC recommendation. So, for example, in a few years back, that was 108, and then 116, and now that are 118 elements. Scientifically, the research about the elements is crossed 150, but the recommendation of IUPAC, that means International Union, International Union for Pure, P for Pure, and Applied Chemistry. International, U Union, P Pure, A Applied, C Chemistry. International Union for Pure and Applied Chemistry. IUPAC, that is an organization which is related with chemical names, nomenclature, rules of naming the elements, compounds. Okay. So the IUPAC at present time recommended 118 elements, out of which 92 are natural. That means they are found in nature up to uranium. The first element is hydrogen, and the 92, which is uranium, that is last natural substance till now. Okay, and the rest are man-made. That means above the 92, that is uranium, after the uranium, these are man-made. That means they made in labs. Okay. If we consider the physical states of elements, then there are 118 elements, out of which 2 are liquid. One is mercury and one is bromine. One is mercury and second is bromine. And 11 are gases. 11 elements are gases, that are hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, radon. These 11 elements are found in gas states, while the remaining are solids. 2 are liquid, 11 are gases, and rest are solids. Okay. Now, let me move to the second type of pure substance, which is compound. Which is compound. Okay. As we consider its definition, then we can say that compound is a substance which composed by two or more types of elements that are chemically bonded in a fixed ratio. Compound is a substance which composed by two or more type of elements that are chemically bonded in a fixed ratio. Or if we consider the general definition, then we can also say that compound is a substance which is made up by chemical combination of two or more elements or atoms, two or more type of atoms. Okay. For example, NaCl. Here Na and Cl. H2O, one is hydrogen element, one is oxygen. CO2, one is carbon, other is oxygen. NH4Cl, ammonium chloride. There are three elements, nitrogen, hydrogen and chlorine. Ferric chloride, there are two elements, one is iron, Fe, that is iron, one is chlorine. Okay, so these are called compounds. Now, there is various properties, out of which some of we will discuss here. First one is the composition and the properties of a compound is same throughout the sample. Suppose that is a sample in which that is a pure water. If I check the chemical properties, then they are same in entire sample. That means if I check here, here or here, they are same. Got it? Clear? Second, the properties of compound are totally different from the constituting element. The property of compound is totally different. The property of compound are totally different from the constituents elements. For example, that is water. It is made up by the hydrogen and oxygen. If we consider the individual properties of hydrogen and oxygen, then hydrogen burn with the pop sound. That means it is the inflammable substance. It burn with the pop sound, while oxygen gas helps in burning. Oxygen gas helps in burning, but the water do not burn. That means it is non-inflammable and do not help in burning. Do not help in burning. Got it? So its property is totally different from its constituting atoms. Okay. Now, our final topic of the chapter is difference between the compound and mixture. Difference between the compound and mixture. Okay. To understand it, let we do an activity, because without activity we cannot compare between the mixture and compound, because both of have elements, both of that means mixture and compound have elements. So to understand the differences between the mixture and compound, let me perform an activity or try to understand with an activity. In this activity, suppose there is a mixture of 50 gram of iron and 3 gram of sulfur. 50 gram of iron and 3 gram of sulfur. Now we divide it into two parts. First is group first and second is group second. We will do different function with these groups. These groups. First thing we do with the group first, that crush and mixed it properly. Crush it, iron and sulfur, and mixed with properly. That means we can say we mixed iron and sulfur. Okay. Now in second group we crush, mix and heated it strongly. Crush it, mixed it and heated strongly so that iron and sulfur react with each other and make a substance FeS. Here let me clear you, here they are just mixed but they do not chemically combined, but here by the strong heating they mixed with each other and make chemical compound. Now we do different kind of tests with them. First, that is test of magnetism. Second is test of dissolution, and third, that is the test with the acid. First one we will do magnetism, check the magnetism. Second, dissolution, and third is reaction with acid. Okay, in the check the magnetism, we bring a magnet near to these groups. In dissolution we add carbon disulfide, carbon di we add carbon disulfide. Okay, and in the test we add dilute hydrochloric acid in these groups. Let me consider the first group. What happened here? When we bring the magnet, when we bring the magnet near to this, that means group first, that is mixture of iron and sulfur, the iron get attracted towards the magnet. Iron get attracted towards the magnet. When we do the dissolution test, in this when we add carbon disulfide, then the sulfur dissolve in it and iron remain. In this the iron attracted and sulfur was remain. Here sulfur is dissolved and iron is remain. And when we add dilute hydrochloric acid, then a colorless, odorless, that means smellless gas is obtained. Colorless, odorless gas is obtained. On burning test we hear the pop sound, and as we discussed, pop sound is the identification of hydrogen gas. That means this is hydrogen gas. When we do similar these three tests with the group second, in which we mixed iron and sulfur and heated strongly, when we bring the magnet, no iron piece attracted towards the magnet, that means nothing observed here. Similarly, when we added carbon disulfide CS2, then sulfur does not dissolve in carbon disulfide. And when we add dilute sulfuric acid, then a colorless gas having rotten egg smell is produced. This gas which have rotten egg smell is hydrogen sulfide gas. Now the question come in our mind that what is happened here? We take iron and sulfur in the both, then why there is a different kind of behavior, and why there is a different kind of behavior? It is because that was mixture and here that was compound formed. Initially both have iron and sulfur, but here that is just only mixed. That's why iron and sulfur do not lose their identity and do not make any new substance. They are just mixed with each other. That's why when we tested, then they give tests separately. Like iron give the magnetism test and sulfur give the dissolution in carbon disulfide test. But here iron and sulfur combined and make a compound, that is FeS, that is ferric sulfide, iron sulfide. Because of the formation of the iron sulfide, the iron and sulfur lose their identity. That means now they cannot give their identification test separately because now their properties is changed. That's why here it do not attracted toward the magnet, and here the sulfur do not dissolve in carbon disulfide gas. Carbon disulfide solution. Got it? So that was mixture and that was compound, and they have different properties. Now the questions come about the gases. Here iron react with the dilute sulfuric acid and substitute hydrogen and combine with the SO4, that is sulfate. That's why here the reaction is given, that is H2S. Here FeS combinedly react with the dilute sulfuric acid, in which iron substitute the hydrogen and make FeSO4, and the substituted hydrogen attach with the sulfur and make H2S. That means here iron and sulfur gives their test separately, but here they gives their test combinedly. They lose their identity, their properties. So that is the difference between the mixture and compound. Now if we consider in theoretical manner, then we can say that in mixture the substance, which either element or maybe compound, just mixed, no new substance is formed. As we discussed in the activity, the group first, which is mixture, there is no new substances formed, because if there is new substance, if there was new substance formed, then the mixture will not do not give the properties of iron and sulfur separately. Got it? But in compound, substance which either be element or compound, react to form new compound or new substance. Here no new substance is formed, here new substance is formed. Now they do not have fixed composition. There is no fixed composition. In mixture, the substances can mix in any ratio. That depend on us, that we take 50 and 3, we can take 40 and 2. That's a matter of our choice. But here in compound, they always have fixed composition. Always have fixed composition, because in the compound they have fixed chemical formula, so they have fixed ratio of constituting substances. Third, the constituting substances shows their property, that means they do not lose their identity. In the test we considered it that iron and sulfur does not lose their identities, they shows that with separate reaction. But here in compound, the properties of new substance is totally different. That means the constituents loses their identity. The constituents loses their identity. The property of new compound is totally different, from the constituting substances. Okay. Now the fourth, the constituents can be separated by physical method. The components can be separated by physical method very easily. For example, if we apply the magnet, then iron separated and sulfur remain. And similarly, if we dissolve in carbon disulfide, then sulfur dissolved and iron remain undissolved, so we can easily separate them. But here the constituents cannot be separated by any physical method. As we discussed, when we applied the magnet, is the iron separated? No. When we added carbon disulfide, is the sulfur dissolved? No. So we cannot separate by physical methods. They can separate it by chemical or electrochemical methods only. By the electrochemical, with the help of electricity, we can decompose, or by any other chemical reaction we can separate, but not any physical method. Okay, hope you like it. And one more thing, that be ready for the test in this week or maybe in next week. You will have to give a test. Okay, thank you.